Now let's talk about implementing a heap. We usually use an array to implement a heap, even though a heap is conceptually a binary tree. But because heaps are complete binary trees and we don't have holes in them, it's more efficient to implement them using an array. We can simply store these values in an array. So we don't need a node class with fields for the left and right children. So our heap is going to have a smaller footprint in memory, okay? So here we have a heap with 5 items. We can store these items at these indexes. We start from the root. The index of this item is 0. Then we have 1, 2, 3, and 4. Pretty easy. Now, as part of bubbling up or bubbling down operations, we need to be able to find the children or the parent of a node. That is pretty easy. Look at the index of the 10 and compare it with the indexes of its children. Do you see a relationship? Well, if we multiply 1 by 2 and then add 1 to it, we get the index of the left child. Or if we multiply 1 by 2 and then add 2 to it, we get the index of the right child. So here are the formulas for calculating the index of the left and right children. Now, how can we find the parent of a node? Again, look at the indexes of 10 and 4. How can we get to 1 from 3? Well, we subtract 3 by 1 and then divide it by 2. So here's the formula for calculating the index of a parent node. Now here's what I want you to do. I want you to create a heap class. In this class, use an integer array to store a list of integers and implement 2 operations: insert, which gets an integer, and remove, which removes the root node. Remember, as part of implementing these operations, you need to bubble up or down a value. So we'll spend 20 to 30 minutes on this and then come back see my solution.